So hello, this is the part 3 of our Playmaker 2 C# tutorial, and in this episode I'm going to show you how to create a camera that are going to follow our player. So here I've already set the camera and it's already working. If we try it, you can see that the camera is following the player. If we move forward, it will follow, and if you turn, it will slowly shift the direction to be in front of our player. So we have some sort of a headroom where we can see what's happening in front of the player, so we can prepare for whatever obstacles there may be on the level later. And how I set this up with Playmaker is like this. So basically, under the main camera, I've create a first state, and in this first state we have a get position action, and the first one we are grabbing the player, which is the player C# object here. So we are grab that position and save it to a vector called player position, and I've unchecked the every frame, so it only run once. We only need to calculate the offset, and the second one is the camera position, and also only on the start of the frame. And I've used this vector 3 operator, and we are subtracting the player position are being subtracted by the camera position, and then the result is being saved on the variable called offset. And also make sure that every frame is unchecked. And then once this state is finished, we go to the next state, and for this next state I've set the get position, but in this action I've actually are getting this child object of our player C#. So I've created an empty game object, and I shifted on the Z position, which is 3. So this is basically 3 units from the player. 1, 2, 3. Oh, that is 4. Sorry, it's 3 units, and basically I've grabbed the position of this camera follow. So that's why the camera are always stays in front of the player, so we can see more on the level in front of the player. And I've saved the position into the vector variable player position. We are reusing this because we don't use it anymore. We already declared this player position when we grab the player position, but once we have the offset, we don't need this player position variable anymore. So that's why I'm reusing that variable instead of creating a new variable. And in this state, I've made sure that every frame is checked. So we want to grab the position of the camera follow object under the player for every frame. And on the second get position, I'm grabbing our own position and make sure every frame is checked also. And then I'm using the vector 3 operator to get the follow position by subtracting the player position and subtract it with the offset. So we have the the follow position, but relative to the camera position. So the camera doesn't snap directly to this position, but it stays at an offset, like we have this in our camera preview. So it will stay the same, the distance, which is minus 10 on the z-axis. And then once we subtracted, I've saved the value to the follow position, a new variable called follow position, a vector 3 variable. And then I lerp the value from our camera position, our own position, to the follow position with an amount of 0.02. And then I've stored this new lerp result vector to a new variable called lerp position, and make sure every frame is checked. And then I've set our camera position to this lerp position, and I've also set the every frame to check and the space to self. But I think self or word, it doesn't really matter, because our camera is not parented to anything. So you can set whichever you like, and make sure every frame is checked. So once we've done that, we have this behavior. Okay, so now I'm going to show you how to create it in C#, and I'm going to duplicate the camera first and put it on top here, and then I'm going to rename the camera to C#, and then I'm going to remove the FSM, so we don't have an FSM on the second camera here, and I'm going to disable the first one. And let's create a new script for the camera script. So create a C# script called I've named this camera script, and then I'm going to open the script on the Visual Studio, and then now we are going to we need to declare two transform variables. So I'm going to create a public transform, and the first one is going to be the target, and the second one is going to be the player. And then I'm going also to create a float variable for smoothness, and I'm going to set this to a default value of 2, and I'm going to save this script first. And if we go back to Unity, what I meant with this smoothness is basically this value here. So if I go to the Playmaker and we select the main camera, here under the follow state, you can see that under the vector lerp we have an amount, and we are going to use that smoothness for we are going to apply that smoothness value to our lerp in the script. So it's basically it's going to be used like this value here. And then I'm going to create a private variable, which is a vector3 type of vector3, and I'm going to name this offset. So you see here that we can make this much quicker with script. First, I'm going to type offset, so we are going to assign the value offset, which is derived from the player position, and then subtracted by our camera position. Camera position, like this. Okay, so now we have our offsets, and then I'm going to close this first because I cannot save it somehow. So I'm going to save this, and then I'm going to go to our project here and then try to reopen this. Okay, so hopefully this is fixed, and I'm going to change the update to fixed update. Somehow it works better if your camera is on fixed update, if your player movements are using the physics rigid body velocity movement. So I'm going to use the fixed update, and here we are going to apply to set the position of the camera to a new lerp value between our transform position, which is our own position, the camera position, and then I'm going to set to the target position subtracted by our offset value here. And then for the smoothness, we are going to use the smoothness value that we have declared on top here, and then we are going to time this by time dot fix delta time. So we are going to make sure that smoothness are being applied over a second, not over frame. So it will be consistent for every second. The value, the smoothness will be 2 or whatever value that you will input on the inspector. And once we have this set up, I think we are done. So let's try this. Okay, so go back to Unity. I'm going to apply the script to our camera C#, and then let's drag this script, and we have 2 slots. So first one, we need to put the camera follow in the target slot, and we need to the player C# to be on our player slot, and the smoothness I'm going to set this leave the setting leave the default value, and let's play this and see if it's working. So there you go. As you can see, we have a exact behavior like we have created in Playmaker, and as you can see, it's really quite easy to get position and then reapply by set position by using lerp, and you can make it very very easy. And for me, with Playmaker, it can be quite quite complex if you don't quite grasp the theory behind it. So hopefully this tutorial is quite clear, and if you have any questions, just uh, ask in the comment and I will do my best to answer it. I hope you find this useful. Thanks for watching. I see you in the next episode. Bye.